So today I will talk about scalar or dot product. So let me first talk about that what is scalar product. So scalar product is denoted by, if I talk about scalar product of A and B, these two vectors, then their scalar product is denoted by A dot B, and it is the product of magnitude of these two vectors multiplied by cosine of the angle between these vectors. So mathematically, this A dot B is equal to magnitude of first vector into magnitude of second vector and cosine of the angle between them. So that means if I am having a vector A, say it is x-axis and y-axis, and here it is a vector A and here is another vector B, then if theta is the angle between them, then their dot product is defined like this, right? Now since so it is the cosine of angle between vector A and B, but as we know that angle remains the same, so that means cosine of angle between A and B is equal to cosine of angle between B dot B and A. So keeping this in mind, I can write down that A dot B is equal to B dot A. That means it is commutative. Let us have a look at another way to look at dot product, and that is very important. We need to look at dot product. So for this, consider a vector A and say there is another vector B, and say these are making an angle theta, and if we draw a perpendicular from B to A, then this distance is basically the projection of vector B along vector A. And let me call it as point A, it is P and it is Q. So now this A dot B, it can be written as magnitude of vector A, magnitude of vector B, and cos of theta. And if I take a triangle OQP, then in this triangle OQ over OP is cos theta, so that means OQ is equal to OP cos theta, and OP is nothing but it is the magnitude of vector P cos theta, and this is nothing but this is the projection of B along A. So therefore I can write down it as vector A vector A into B cos of theta, it's put together and it is the projection of this. So that means I can write down vector A, its magnitude, and projection of vector B along vector A. So I can put it like this, right? So this is a new way to look at the dot product. And similarly, if I take another diagram, means if I will make a diagram, sorry, it's a vector A and it's vector B, and if I draw a perpendicular from this to this over along this distance is basically, it is the projection of a vector along vector B. And if I take this as point O, this as point Q, and this is point P, then using triangle OQP, if I use this triangle, then according to this, OQ over OP is equal to cos of theta. So that means OQ is equal to OP, means this OP is a vector, so mod of A cos of theta, and this is the projection of A along B. So keeping this in mind, I can also write down A dot B as A B cos of theta, and here B can be written like this, and it is A cos of theta. Then this is A cos theta is nothing but it is the projection of A along B. So this is a new way to look at it. Look at the dot product. Now let me write down dot product in terms of Cartesian coordinates. Means dot product in terms of Cartesian coordinates. So if we talk about it, then the vector A, it can be written as AXI cap, AYJ cap, AZK cap, and similarly the vector B is equal to BXI cap, BYJ cap, and BZK cap. And let me try to find out that what is A dot B. So it is AXI cap, AYJ cap, AZK cap. Similarly, AXI cap, not AX, but it's a BX, BXI cap, BYJ cap, and VZK cap. Here it is AXI cap, it is BXI cap, BYJ cap, and VZK cap, plus AYJ cap, BXI cap, BYJ cap, plus BZK cap, plus AZK cap. It is AXI cap, AYJ cap, and AZK cap. So what it will be? So it is AX BX, it is I cap into I cap, plus AX BY I cap J cap, and AX BZ I cap K cap. Then it is AY BX J cap I cap, plus AY BY J cap J cap, plus AY BZ J cap K cap, and then it will be AZ BX K cap I cap, AZ BY k cap, j cap, az, bz, k cap, k cap. Now the angle between I and I will be 0, so that means its value will be 1. J and j angle will be 0, so its value will be, cos 0 is 1, and here angle is also, so it's 1, and this is also 1, and the angle between I and j will be 90 degrees, so its value will be 0. It is also 0, it's also 0, it's also 0, this is also 0, so this is also 0. So that means the value which we are getting is basically this a vector dot b vector is equal to ax ay, sorry, ax bx, a by by, and az bz. Right, that's what we are taking. So here I have used the concept that I dot I is equal to 1, or I can say that it is j dot j, it is also equal to k dot k, and its value will always be 0 because the angle between similar vector will be 0. Similarly, I dot j is equal to j dot k and k dot I, the angle between them is 90, so it's sorry, here it is 1 because cos 0 is 1, cos 0 is 1, and cos 90 degree is equal to cos of pi by 2, so it's always 0, so that's why its value will be 0. We have used these things here and we are getting this one. And let me talk about another properties. So if A and B are perpendicular, means A is perpendicular to B, what does it mean? If they are perpendicular, then we can say that A dot B is equal to A dot B, their mod and cosine of angle 90 degree, because they are perpendicular. Sometimes it's written as pi over 2. So cos pi is always 0, its value is be 0, so that means it is 0. So that means two vectors are said to be perpendicular, that means their dot product is always 0, right? And if A is parallel to B, what does it mean? It means that A dot B is equal to A B cos 0, and cos 0 is always 1, so that means it is simply AB. And if they are anti-parallel, so for anti-parallel the angle theta will be equal to 180 degree, so that means A dot B is equal to mod of A mod of B cos of 180 degree, its value will be -1, so that means A dot B is equal to minus AB. This is the condition for the two vectors to be anti-parallel in terms of dot product. And let us talk about few examples of scalar product. Examples of scalar product. Examples of scalar product. So first example, let me talk about same work is defined as f dot dl. So it is one example, and where f is the force and this is the displacement vector, and kinetic energy is also known as half mv square, so it is half m, it is v dot b. So where v is the velocity, and sometimes it can be represented in terms of momentum, so it is p square by 2m, so it is p square by 2m, so it is P dot P over 2m. This is another way to look at it. Similarly, power is defined as this P is equal to F dot B. V is the velocity and F is the force. So thus power is also a scalar product in turn. And electric flux d phi E is basically E dot ds. It's also a scalar quantity, scalar product. So where ds is a area vector. So these are few examples, and let us do some problems, right? So for that, consider problem. Say we have to find out the value of C. Find value of C if A is equal to 2i cap plus 3j cap plus 5k cap and B vector is equal to 4i cap minus 2j cap plus ck cap are perpendicular to each other. So for these two vectors to be perpendicular, as we know that the dot product must be equal to 0. So let us put their values. So it is 2i cap plus 3j cap plus 5k cap into 4i cap minus 2j cap plus ck cap is equal to 0. So it is 2 into 4 plus 3 into minus 2 plus 5 into c is equal to 0. So it is 8 minus 6 plus 5c is equal to 0, which implies 5c is equal to minus 2, which implies c is equal to minus 2 upon 5. So this is the value which we are getting. Also take one more example or one more problem. Find angle between two vectors. These are very simple problems which I am discussing here. Find angle between two vectors. Say vector A is known as 2i cap plus 2j cap plus 3k cap and B vector is equal to 3i cap plus 3j cap plus 8k cap. So as I know that this A dot B is equal to AB cos of theta. So from here I can write down that cos of theta is equal to AB over AB, and let me put their values. It is 2i cap plus 2j cap plus 3k cap, 3i cap, 3j cap plus 8k cap whole divided by their magnitude. So it is 2 square plus 2 square plus 3 square under the root, and it is 3 square plus 3 square plus 8 square under the root. So what I am getting, it is equal to 2 into 3 plus 2 into 3 plus 3 into 8 divided by, this is 17 under the root, and it is 82 under the root, and here it is 36 upon 1394 under the root, and it is 36 upon 0 point, sorry, not 0 point, but if I take it square root 1394, it is 37.36 nearly. So that means cos of theta, the value which we are 96421. So that means theta is equal to cos inverse of 0.91421. So if I take inverse, then its value will be nearly equal to 15.42 degrees. So therefore the value of theta will be equal to 15.42 nearly. So here in this lecture today I will discuss that what is a dot product and what are some examples of dot product, and try to do few problems on the dot product. So that's all for this lecture.